Well, good morning, everyone. That was a great presentation from Battle Motors there. I will definitely take them up on their offer. We'll take about 10 trucks in Austin. If you could do that for us and send a couple drivers as well. So that would definitely help us out. But this perfect segue to our next presentations about innovations and technology. And we have 4 great speakers here today to talk about some changes in the industry, things that can help us improve our operations at home, and different ways that they can do this, and some innovative things. And I've had a chance to hear a few of the items, but I think we're in for a good presentation here. Our first speaker will be Daniel Domanowski with Potential Industries. They work with Murph Technologies in order to get a cleaner sort from their materials. Our next speaker will be Connor Riffle with Rubicon, and he'll talk about ways to optimize our routes. Very important nowadays, as we're all a little shorthanded on drivers, and as we can make the most of those routes, something that we definitely would like to do. Next speaker will be Aaron Levine with Vespine Energy, and his company has come up with a novel approach of capturing landfill gas and channeling it into productive and potentially lucrative uses. And rounding out the panel will be Dave Yonke, and Dave will talk about how you go about deciding whether to evaluate new technologies and how to invest in those technologies and whether it's worth it for your organization. So with that, I think Daniel, you'll lead us off.
Good morning, everybody. I'd like to start by thanking Alex and Juby and the team for putting this conference on. It's my pleasure to be before you today to talk about Murph Technology. They asked me to take about 30 years of experience and boil it down to 8 minutes in a concept that everybody can understand. So here we go. I'm going to look at the evolution of the industry, Murph equipment and technology. This is my life's work. This is my passion. I've been visiting Murphs in the United States for 30 years. I've probably been to 50 or 60. And when I talk about a Murph, of course, we know it's a material recovery facility, but just for the sake of clarity on the slide there, and I only have 4 slides, we're going to keep this brief. We're going to power right through. We're going to talk about clean Murphs. Of course, a clean Murph is where the recyclables have been picked up separate from organics and from municipal solid waste. I'm going to boil this down to 3 areas, traditional technology, and then for something that's more advanced, we'll look at detection and separation. And detection and separation are really where things are at. So let's start with traditional. All Murphs basically work the same way. We have a bunch of conveyors. The capacity of the Murph is determined by the width and the speed of the conveyors. Typically, it goes through a pre-sort, and we hit some screens. So on the slides here, you can see there's shafts which have discs, and then there's a series of these shafts in succession. And depending on the spacing of the shafts and the size and shape of the discs, some stuff goes over the top, some stuff falls through, some stuff might roll off the back. So screening, mechanical screening, is the most fundamental part of all Murphs. Then we get into some very simple technology, which is just magnets. There's an overhead crossbelt magnet, get off some things. We also put magnets in head pulleys. So we can have a traditional magnet to get off metal, or we can have an eddy current where we separate the aluminum and there's a rotor spinning inside that's electromagnified. If you've ever taken 2 magnets, put them together, and they kind of like push themselves apart, that's the current that's created to repel the aluminum off. Finally, we have density. This is simple stuff. Something goes off the end of a conveyor. It may or may not fall on a rotating bin. There's a stream or blanket of air, which is taking light stuff, pushing it over the top, and heavy stuff doesn't go over. So that's how traditional Murphs work. And now we can get into technology. So I'd like to just have you all think about how simple this is. Something is going to detect something, and then it's going to separate it. That's all there is to technology in Murphs, advanced technology, that is. So cameras will measure shape. They do recognition of shape, or they do color. So there's information from the camera, gets sent to a computer. And then we have these near infrared light waves. You can't see them, but they're there. The light waves go down, light waves come back up. You can see on the end there, positive going down, negative coming up. The optical sensor determines what it thinks that is, sends the message to a computer. The third thing that we do, we also use magnetics for detection. We kind of insert them within the conveyor belt themselves. So if there's any type of metal that's going across the conveyor, we can detect the presence of metal. So now this detection, you have 3 sources of data, goes to one location. At this location, a computer decides, should we try to separate this or not? According to TOMRA, one of the largest optical equipment providers in the world, they consider this to be a form of AI. So artificial intelligence, there's either like smart artificial intelligence, when you take those 3 types of data, you figure out what to do, or you can have dumb artificial intelligence, which is just, hey, here's a PET bottle. See that? That's a PET bottle. This is another PET bottle, but it's crumpled. And you do this like hundreds or thousands of times. And you develop this database where now the computer is going to be searched each time, AI, to determine what is that. So that's not very common. But detection is the first part of applying technology. As I said, it is really simple. So after the computer takes this data, figure out what it wants to do, it's got to separate it. There's 2 forms of separation in North America today. Little puffs of air. You have a manifold, it's the width of the conveyor. It's got all these nozzles attached to it. It's hooked up to the computer, little puffs of air. You can adjust how strong the air is, how many of these nozzles fire at the same time, how long does that puff of air go? So if you're ever in a MRF and you hear all this, that's what you hear, the little puffs of air. You can separate big pieces of cardboard. You can separate a small yogurt tub. So if you look at the red is basically conveyors going along. At the end of the conveyor, depending on the speed of the conveyor and the density of the material, it wants to fall off a certain area. But the first, this is a 2-way optical sorter. So this one, there's a manifold up above. It's like, get down. I want you over here. And then maybe the default is over here. Then there's another optical blast of air, which can like push it up. It only has to move it like inches. So it's falling off the conveyor. It just has to move this way a little bit or that way a little bit. And that's how you're sorting using air. It works great. The other way to separate is with robots. And robots, there's 2 types. There's basically ones that suck and ones that clasp. Most popular ones are the ones that suck. And so just think of like if your toilets, you have a plunger for your toilet, right? And if you have a sophisticated plunger, at the end of it, there's this little thing that steps down. That's like what this robot thing is doing. It's positioned over the conveyor. Every time the computer says, go get it, it moves over, goes down, tries to suck a little bit, pick it up and move it somewhere. And depending on where you want to move it, it's either got to go here or here or here or here. This one, I'm showing the robot, which is in the middle, could actually take and pick up, it could drop something that it picked up into 6 different locations. So one of the common forms of robots is doing post-sort quality control on PET and other things. So it's like, oh, you have an aluminum can, put it over there. If you have a HDPE, put it over there. So basically, robots and optics are key to technology that's today. So I'm going to just kind of conclude by bringing it all to a close. I am not here to say, guess what? Technology is the answer for MRFs because we've got all these things and so they work great. It's fully autonomous, AI, just put, it takes people, takes traditional methods, it takes technology. But all that stuff doesn't work if you have highly contaminated material or wet material. That's why CalRecycle, statewide commission, they're promoting right now clean, dry material. So I'll close by saying that as a MRF operator and an expert in the field of marketing, what we like to focus on are 2 things: material that's recoverable. The system that I just described is capable of separating it, and marketable. And by marketable, I mean consistent markets at reasonable qualities. So we're not going to try to make something with 10% contamination and say you should buy that, but we're not going to make anything that's contaminant free. So that concludes my presentation. I hope you've learned something about MRFs and technology.
Great, thank you. Our next speaker will be Connor Riffle, and if we'll take questions at the end of all the presentations, and then those of you that are joining us through Zoom, if you can use the Q&A function on there, we'll also look at those for potential questions. So Connor, you're up.
Well, thank you so much, Richard. It's great to see you. Thank you to Alex and the LA team for hosting us. And it's great to see so many old friends here at MWMA, one of my favorite conferences of the year. So thank you for having us. I want to talk a little bit about some of Rubicon's software technology for waste processing, as well as for fleet optimization. Some folks will know Rubicon. We're one of the largest waste collection companies in the country. We manage about 8 million service locations around the country, many brands that you know and love. We do for example, every 7-Eleven in the country, every Sweetgreen, every Walmart. These are all of our customers, and we help them reduce the amount of waste that they send to landfill and therefore save money on their waste collection operations. We also support many cities with our city software technology, helping waste departments run their collection operations much more efficiently. This is the technology that we put into the vehicles and empower your dispatchers and your managers with, really to help municipalities drive down the cost of waste collection, which, as we know, is the most expensive part of the waste value chain, the cost of collection. So most folks here, some folks, your municipalities will own MRFs, but probably a larger percentage of you will actually own the vehicles that do the residential and commercial waste collection in your city. And this is the area that we focus on, trying to empower cities to do that waste collection at the lowest possible cost. And with the highest amount of safety and sustainability built in. So a core component of that, as Richard mentioned, is our ability to actually optimize residential routes. And I have a lot to say on fleet optimization and the best way to optimize your routes, but the core of it is the algorithms behind high density routing, which are different in the waste industry. As we all know, you all will know that taking Google Maps and trying to run your trash trucks through it doesn't work. So the key to fleet optimization for us starts with those really solid algorithms for high density routing, which allows you to go to every single location, every single house in a particular city on a weekly or bi-weekly basis. We do that with the technology that you see on the screen. Usually it's as simple as just putting an iPhone in your vehicles. And a number of our folks here that we work with can attest to just how easy this is to get up and running, get installed, and be able to start saving money right away. We also have some camera technology, which I'm going to talk about a little bit because we're doing some really interesting things to actually take the processing of waste materials away from or I should say, do some pre-processing of these waste materials, not at the MRF, but actually on the backs of the vehicles themselves that y'all are using every day to collect waste. So I'm going to talk a little bit about some of the pilots that we've run, actually putting cameras in vehicles in the hopper of the vehicle to actually detect contamination at the source. So at the moment that the bin that your hopper in your vehicle is contaminated, we can actually begin to detect if what those contaminants are, and then that particular load has been contaminated. And this is quite useful. So we ran a pilot with the city of San Antonio, and it was a very successful pilot to actually put these cameras into their organics collection vehicles and begin to detect that contamination at the moment of tip. And just a shout out to the city of San Antonio, the fantastic innovation programs called CivTech SA. Y'all need to get yourselves one of these programs. It's a great way for testing new cutting edge technology. And so if any folks are here from the city of San Antonio, it's a great program to look into. But we're able to come in as the innovator in residence and actually build this technology in partnership with the city of San Antonio. The brief that they gave us was to detect contamination in their organic streams, but the same philosophies and the same software development applies to detecting contamination, for example, in a recycling stream. You can see in these photos the way that it works, but we put that camera in the hopper. And at the moment that organic stream is tipped, we can actually detect certain materials if they're present. So things like plastic, wood, plastic bags are often the biggest contaminant, aluminum cans, things that might not, that shouldn't be in that that bin, but may find themselves in that hopper. What that allows us to do then is say, okay, this particular load has been contaminated, and we can actually tell you the street, the route, and the street, and even maybe eventually the address where exactly that was contaminated. And that allows us to know which loads are contaminated, and then to begin to target recycling education, contamination education to those particular streets, and build up a heat map of the areas where that contamination is actually happening. So this is very cutting edge technology. The burden, I think, for contamination is often on the municipality, and often that in these contracts is put on the municipality by the material recovery facility operator. And I think part of the path out of contamination is to actually help municipalities do more to partner with their MRFs. And technology like this can really help to take the burden of identifying that contamination away from the material recovery facility operator, and actually put it a little bit on the truck, so we can actually see if these loads are contaminated before we go in. So this is, again, emerging technology. We've piloted this in a number of other cities as well. But as you're thinking about ways to handle contamination, I know we talked a little about that yesterday. Thinking about ways that you can use software to actually begin to process the detection of contamination on the vehicle is a really, really interesting area. And I'll just leave you with a few other thoughts. One is the national average for contamination. I mean, we know is extremely high, right? 17%. So there's a massive opportunity. And we know that a lot of these loads that are arriving at the MRF are contaminated. And we know that often the municipality bears the burden of that, right? Oh, if we deliver X number of contaminated loads to you, then we are penalized in some way, is a common way that these contracts are set up. So we can potentially see a reduction of rejected loads by up to 50% by actually putting this type of technology into the vehicles. So there's some really, really interesting areas going on here. I will say that with any technology, the key is actually implementation, and we've seen this over and over. We have a long track record of actually implementing new technologies in municipalities, working with municipal workforces, looking at ways that we can support these municipal workforces in making a technology transformation. We've done that over the last 5 years as we've transitioned folks away from paper-based routes and kind of what I would call manual route optimization, and moving them from that to a digital operation. This type of technology, detecting contamination automatically, is no different, right? We have to bring our workforces along with us as we do that. So, we've thought a lot about best practices and how to engage drivers, how to engage staff in making that transition. It's not just enough for us to make technology and software and throw it over the wall to y'all and say, hey, have fun with it. We actually have to work together in implementing that technology so that you don't have to, it's a little bit of an easier path for you in implementing that technology. Driver engagement is a really, really big part of that. Y'all will have driver engagement programs, something we specialize in, and in working with your drivers to help them make that transition away from their kind of their old practices to their new. So that was a lot in 8 minutes. If you want to hear more about some of the innovative software technology we're rolling out in municipalities around the country, please let me know. We'd love to chat more, and looking forward to the discussion. Thanks.
Thank you, Connor. Great information there. Next, we'll have Aaron with Vespene Energy.
Hi, everybody. Thank you for having me. Thank you, Alex, and thank you, Juby, for putting this on. I'm here representing Vespene Energy. Vespene Energy is a renewable energy developer and a methane mitigation company. Before I get into exactly what we do, I'd like to just sort of set the table as to the problem that we're trying to address. So methane is an issue. Methane is a problem from an environmental perspective, but it's also a valuable resource when used correctly. The EPA estimates that landfills contribute about 17% of US methane emissions. However, there was a study back in 2019 that was done in partnership with NASA that said that these figures when they looked at landfills from an aerial perspective using satellite technology, they found that the emissions were actually greater by a factor of 2 to 3x. This would potentially suggest that landfill represents the single largest contribution to US methane emissions from all human sources. There was also a recent study in 2021 that was put on by the United Nations that said that curbing our methane emissions represents humanity's single and greatest lever in combating climate change. Traditionally, landfills have two ways to beneficially use their methane. They can either build a power plant, process the raw landfill gas, generate electricity, sell electricity to a grid, or they can build a refinery, refine the gas to pipeline quality, again, connect to a grid or inject into a pipeline. In both cases, these project types require a lot of time, a lot of money. They both require infrastructure and connection to either grids or pipelines. And so as a result, a large majority of landfills don't qualify for one of these two projects because the economics simply do not pencil. So of the 2,600 landfills that are tracked by the EPA domestically, only 28% have viable projects, which would be represented in one of these two project types. That's where Vespene comes in. So Vespene provides an alternative to the 78% of landfills that are currently not being serviced by these two project types. And so what we do is it's essentially a landfill gas to energy project. So we bring our power generation equipment to the site of the landfill, we generate electricity, and then we bring the consumer of the electricity on site in the form of data processing. So instead of exporting electrons in the case of a power plant via a grid or molecules via a pipeline, our product is data. So we're converting that electricity into data on site, thereby eliminating a lot of the costs associated with the two previous project types mentioned. This unique approach to this problem has three various solutions. The first is for all these landfills that didn't have a way to beneficially monetize their gas, we provide a new revenue stream, converting a liability into an asset. So a number of times you'll have the EPA regulating these landfills that they have to collect and destroy their methane in the form of a flare, a candlestick flare. And a flare can cost upwards of $1 million. It can be $50,000 to $100,000 a year in terms of service costs. We convert that into an asset that's actually producing revenue. Secondly, from an environmental perspective, as I touched on earlier, methane is a huge environmental issue. One molecule of methane is the equivalent of 84 molecules of carbon dioxide when looked at through a 25-year view. And so mitigating methane has huge environmental benefits. And then thirdly, as we all know, landfills are largely owned by communities and municipalities that don't have lots of levers for additional revenue generation. We provide these communities with a direct revenue stream that's meaningful on a regular basis. The way that our system works, we call a self-sustaining microgrid, and you can see it illustrated here. So basically, you have a landfill producing raw landfill gas. We then take that landfill gas, run it through a gas conditioning system to remove impurities, siloxanes, VOCs, et cetera. We then take that filtered gas, run it through a micro turbine or an internal combustion engine, depending on the needs of the site. We then take that electricity and we power on-site data processing. And so by bringing the user to the site, we're able to monetize the gas, mitigate the methane 24/7, 365 on a continual basis. There's a lot of key features to this solution. Firstly, we turn, as I mentioned, a liability into an asset, a high margin producing asset. Secondly, we're fast and scalable. We can be up and running on a site in a matter of months as opposed to years. Thirdly, we're fully self-contained. We don't require any connection to a grid, and we're entirely black start capable. Fourth, we provide a hedge to RNG. As we all know, there's sort of a gold rush in the RNG business, but that is a market-driven, the RINs associated with RNG are market-driven. And so if you want to have, from a portfolio perspective, if you want to have some hedge to, a decline in those credits over time, we provide a flexible hedge. Fifth, we're complementary to other projects. So if you are developing an RNG project, but that site won't be operational for 4 to 5 years, we can monetize the gas in the interim and mitigate the methane while you're building up to your RNG project. We're also an applicable solution, one of the only solutions that we've come across that works for closed sites. You know, as we know, landfills after they're closed continue to produce landfill gas for 10, 20, 30 years after they've been closed. There is a declining methane curve, but within the range of what we're able to service. And then lastly, and this is a larger topic that we can get into perhaps later, it lays the foundation for future electrification. So as we've heard from the Battle Motors team, there's a huge press to electrify fleets. Landfills present themselves as a perfect place to do so, given the number of different vehicles interacting on a landfill site. Because these landfills are often remote and decentralized and don't have access to the correct power capabilities required to charge vehicles, we can actually accelerate a site's ability to purchase and scale into vehicle charging because we can generate electricity on site for those needs. I think that sort of wraps up my presentation for today. If you have any questions, would love to chat further after. Thank you.
Thank you, Aaron. And our last speaker, Dave Yonke.
Wow, those guys are really smart. So if those of you that know me, you're probably wondering why Yonke is on a technology panel. And that's a fair question. So hopefully I will answer. So this is really interesting. In all seriousness, we had Battle Truck here talking about their vehicles. That was fascinating. But you heard right now, I mean, there's so many technology opportunities out here. You heard on the routing software, we're listening and talking about the landfill energy projects and evolving MRF technology. So you have all those things that are out there. And you have to consider, how are they going to impact your utility? How do you participate in that? Should you participate in that? So where I'm coming from on this side is, how do you quantify the financial benefit? Should you do it? These things are great. And I'm excited to see these things, these technologies move forward, the routing, you know, electric EV vehicles, et cetera. But at the end of the day, to get the money, to get the capital, you probably have to sell your council or your commission or your board on investing money. It may be hundreds of thousands of dollars or millions of dollars, but you've got to be able to justify it. So how do you do that? When we get hired to do feasibility studies, the vast majority of feasibility studies that we do follow this format. So if you listen to nothing else and other than what I say here, if you are evaluating options, if you're looking at something, I'd strongly recommend you consider this approach. When we're looking at, for instance, we've had numerous clients ask us to look at different recycling options, okay, for them. And I'll show a couple examples very briefly. We always start with, what does it cost you right now to provide that service? So kind of your status quo. And that means that has to be all your operating costs. It has to be your labor, your benefits, fuel, vehicle maintenance, all of those operating costs, capital costs, your rolling stock. We always amortize it. What's your frontline equipment? You know, how many routes are you running? So you have an idea of what it costs you. You've got to have an accurate number, and then you can do your what ifs, your other scenarios. So let me just show you a couple examples. We did this project for Stillwater, Oklahoma, a couple years ago as part of a solid waste master plan, and the local MRF was going to shut down. And so they, you know, Stillwater, it's a college town, OSU's there, Oklahoma State University, very, you know, they want their recycling, but now the nearest MRFs were potentially either going to Tulsa or Oklahoma City, so about 80 miles each way. And they're like, Dave, we need to know the most cost-effective option. And so we've got to quantify. So what we did, and I apologize, that should all be in black, it doesn't matter. I was breaking that out. And anyhow, what we did was the first scenario was the status quo, and I'll show that to you in a second. So it lets you know what it costs you to currently collect. The second thing we then looked at was direct hauling. If they were to direct haul those vehicles, what's that going to cost? You know, it's going to cost more because those vehicles are off route. You're going to have to potentially add a route, or they're doing overtime or what have you, and also wear and tear on those vehicles. And then they had us look at several different facility scenarios, a recycling staging facility. They had other options with citizen collection centers, et cetera. At the end of the day, what we do, and again, think about who your audience is. You know, I'm presenting this to you, but you're going to be presenting this to your elected officials. And at the end of the day, they're going to want to know, what's this going to cost? Okay. So we put this type of information together. We actually had it in the presentation to the council. It went great. That's what they wanted to see. We showed to them, if you look at scenario one, the status quo, it was costing them about $700,000 a year to run all their recycling routes. And it's a small city. There's about 4 routes, but you know, labor costs, capital, everything. Then when you were direct hauling, it jumped to 900,000 because they had to add a route, again, more distance, a lot of miles on the trucks. Then the scenario 3, there was actually 4 of them that had capital outlays. You can see the far right column shows what it would cost. Now it's over $1 million. And the column, the second column, or the infrastructure capital cost, that shows the capital they'd have to outlay, issue debt. And then the annual cost is all your O&M and the debt service. So bottom line, we're able to show the elected officials, this is what it'll cost for these different options. I didn't put the slide in here. The other thing, if you're doing this, I would strongly recommend, and we've done this in some of our other studies, we then show what it means for on a household basis. So let's say you've got 40,000 households, you divide that number by 40,000 households by 12 months, and all of a sudden, let's say you're at $1.50 per month per household for the base scenario, and the other scenarios $2 per month. That's the kind of information they want. They're going, okay, our rates have to go up 50 cents if we do this, or $1. That's the information that elected officials want. And it's a lot easier to get them to approve those things when you've got that financial data. Last year at this conference in Austin, Jill Holbert and I presented on the feasibility we did for Albuquerque. Just very quickly, the issue was, is it feasible for the city to build, own, and operate its own MRF? And so we put together these 3 scenarios: public ownership, public operation, public ownership, private, and then private ownership, private operation. Okay, when I go to this next slide, don't start analyzing all the numbers and start figuring out if you think your MRF's efficient or not. But this was one we did, and what we did was looked at the O&M costs under the different scenarios. You'll see, and I'm just going to hit the highlights here. For instance, in the first column, public ownership, public operation, again, this is with city employees. They have a city wage scale. They have better benefits than the private sector. So you would expect your labor costs to be better or higher. In the private scenarios, just if you're curious, we talked when we did the study, we talked with about 10 different MRF operators, looked at the range of salaries they were paying, benefits. So you know, we had a pretty strong benchmark for that. On the capital cost side, we looked at capital costs. There are different costs of capital. And then we also look at general fund, because again, we're trying to make this as accurate as possible. So if a city's going to operate it, there's probably going to be a transfer to the general fund, okay? We also put in a profit margin. I think all the MRF operators, they want to make a profit. They're not doing it to be nice. They should make a profit. This is arbitrary. We put in 15% as it. What we did once this was set up on any of these models, and you can do this yourself. This is not rocket science. But once you get a sound foundation, then you can start running what if scenarios off these things, but it helps you to make those decisions. So those are just two brief examples, and that's everything I have. So thank you.
Thank you, Dave. Now I guess it's time for questions if we have any. And folks who are on Zoom, if you just use the Q&A function on your screen, you can ask questions as well. So do we have any questions? Yes, over here. Over there.
It's a message. There's questions for Connor. Thank you for your presentation. Your technology for contamination monitoring. Two questions around that. You know, one, does it quantify contamination, or does it just indicate the contamination exists in the hopper cameras when you're dumping the loads in there? And secondly, you mentioned that you've used it, your clients are using it for education. So they go to a route, that's heavily contaminated and bump up education there. Are you aware of anyone using it for enforcement purposes? Because I think when it comes to, at least in California, 1383, there's going to be a lot of emphasis on outreach and education, as well as eventual enforcement actions related to contamination on organics specifically. So I'm curious as to how your technology may interact with that.
Sure. Yeah, both good questions. In terms of quantifying, the impact or quantifying the savings, I think right now we're at the identification stage, first step. Let's identify it. Let's figure out how we can get the technology, going and effective. Make sure that the images are accurately being identified of contamination. And then what we've done is manually for the partner cities that we worked, we've estimated all those quantity impacts manually. So, that's part of what we'll do, especially as we're co-building some of this technology. I mean, this idea really came out of conversations we had in rooms like this, where, in fact, I remember specifically a panel 3 years ago, where we talked about contamination and just, what a crisis it was. And I remember Commissioner Alcantar from Cleveland, God rest his soul, talking about just how high their contamination rate was in Cleveland. Many folks will remember this, and that's really one of the inspirations for why we built this technology in the first place. So that co-building piece is really kind of core to what we do, and the quantification piece, I think, is part of that. And then on education and enforcement, I mean, I would love to see more people doing enforcement, just generally, right? I would say, and don't take this the wrong way, but there's a massive opportunity to do more enforcement, not just on contamination, but also on some basic things like go backs, right? On missed pickups, on kind of some of the nuts and bolts stuff. I think as an industry for too long, in the political environment, we've said like, oh, well, we're just going to go back, we're going to do that stuff. And that's fine. But as the cost pressures increase, we have to do that enforcement, and we have to kind of draw a line somewhere and say, we're not going to go back, or, hey, we noticed that you've contaminated, so we're not going to pick you up next week, or, whatever, here's a fine or whatever it is. So, it's a challenge, I know, but the cost pressures that, I know all of us are facing right now in cities are very, very significant. And so I would love to see more folks doing enforcement. I think this tech is the first step in that. So we can actually see, okay, the contamination happened here. And then from there, we can make the decision about enforcement. Same thing with go backs. Okay, we see that you didn't set your bin out on time, so now we can think about enforcement. But that technology, having that technology and having that data in your hands allows that next layer of enforcement to go on. Hopefully that was helpful.
I have a question for Aaron. Aaron, can you talk a little bit more about your business model? I couldn't help but to see there's the word Bitcoin up there, and then provide a reference facility or an example where it's actually been executed.
Sure. Yeah. So we use data processing as a way to consume high amounts of energy. It's true that Bitcoin mining is one of the data processes that we're able to deploy. It ends up being a profitable solution, but it's not the only type of data center. As you can imagine, and as the world becomes increasingly more, driven by our phones and computers and access to high-speed internet, a number of different data centers are required to support that increasingly information-driven society that we have. So what we do is we evaluate based on a site basis, what is the most efficient, profitable, and appropriate type of data center to deploy in partnership with our landfill partners. But it is true, Bitcoin mining is, Bitcoin mining has this feature in that it's interruptible. If you're running a Netflix server and that server goes down because you can't commit to 100% uptime, well, that's a problem. You don't want your streaming service to go down. So Bitcoin mining is interruptible in that nobody really cares if it shuts off and turns back on. You just, you miss a little bit of revenue for the period of time that you're down. So that's kind of the first part, in that there are multiple different types of data centers that we can service on a site. It is true that Bitcoin mining is one of them, but we evaluate what is the best, highest, and best use on a site-specific basis. We have one project right now under construction in Central California. We expect for this site to be up and running close to the end of the year, if not early next year. And we have somewhere between 10 to 12 additional projects that are in various stages of LOI and planning to come online in 2023. So we're planning to have an extremely active 2023 and roll out this technology to all the small landfills that couldn't figure out how to monetize their gas.
Charlene, did you have a question?
So Connor, you're integrating with cameras that are already installed in trucks, or are you installing them where they don't exist, or a combination of both?
Both, whatever's easiest, right? Depends on the truck type, depends on what's available. It's a little bit harder to grab the existing stuff, just often because it's closed caption, it's a closed loop, it's a little bit more difficult. But yeah, we can work with that, and we can also work with we can also deploy our own cameras in these scenarios. So whatever's easiest.
I have two questions, if I may. If I could start with Aaron, what size output of gas, or how small? You keep saying small landfill. How small?
Sure. So we can go down to, we prefer to operate in sort of the 400 to 500 SCFM range, but we can go down to 200 SCFM. We can also go down to a lower than traditional methane concentration, so like 38% methane. So generally speaking, fairly small.
That's great. Thank you. And my second question is for Daniel. When you talk about that technology that you very clearly explained, in combination for some of the higher performing MRFs that you've been associated with or you've toured, what numbers are we looking at? How many optical sorters? Do they have robotics? What is kind of the state of the art for using this technology in an active MRF?
At Potential Industries, we deploy over 25 optical sorting units. We have the most advanced in the country. There's two ways for the opticals to get more advanced. One is the wavelength that they can measure. So we have a couple of K9s for our glass unit. I think that the optical equipment in MRFs could range from between 3. I'm not aware of anybody who actually has as many as Potential. We utilize different companies. We don't go OEM and do turnkey installations. So we have 3 different optical manufacturers that we use depending on whether we're sorting glass, fiber, or containers. The robots, there's some that have as many as 20 or more. Oftentimes robots are in the post-sort quality control. One of the reasons that Potential doesn't have any robots has to do with the number of picks you can get per minute. So if you would imagine that a robot, it sees something that it wants, and then it has to take it somewhere, and then it has to come back to where it was and get ready for the next thing. There's a lot of material that's going across the conveyor while it's doing that. If you have a an air manifold at the end of the conveyor with 100 nozzles on it, you can be simultaneously sorting multiple materials. So optical, you can sort between 50 and 250 picks a minute. I think a robot might be around a theoretical of between 50 and 80. The robots are getting much more advanced. When they taught them to sneeze, that was very helpful because sometimes they'd go pick something up and it kind of got wedged in there. And so it would spend time like thinking it's working until it learned to sneeze and then it could keep working. But optical is coming along, and I hope that answers your question.
Yes, thank you.
Do we have any other questions?
This question is for Aaron, and it's very simple. What about altcoins?
We currently don't support anything other than Bitcoin mining and other sort of more traditional data processing.
I don't even know what that meant. So, all right, I don't see no further questions. So if I can get a round of applause for our guests here.
I was not expecting.